Installing NVIDIA drivers is a nightmare on Fedora 44. Stay for the video to see its performance and how it handles the graphics. We enter the official site. This time we use KDE Plasma. It works well with NVIDIA on other distros. We wait for the download. We boot the image and wait for it to load. According to the team, this version brings several updates, mainly administrative development updates, but no improvement is mentioned for version 43 issues, such as the low disk performance we encountered. We run the installer and select English. Then we select the keyboard layout. In this specific case, it is Latin American style. Select how to install. Here we use the entire disk. Then, next, we accept the terms and then click on Erase and install the system. We wait for the installation to finish. As is well known, Fedora is sponsored by Red Hat. There is high expectation for the version. The system boots for the first time. The time is fast compared to other distros. Fedora finishes the install during the boot. In the setup, we select the language again, the keyboard layout. We choose the dark theme. Then we proceed to configure the account. We enter the name, user, password, and confirmation. Then the host name, the location, the time, and the network settings for the PC. Now it enters KDE Plasma with the new login manager. We enter the password and enter the desktop. Then the welcome screen is set. We can configure the desktop. It shows Discover for apps, we can share data, and it mentions that the repositories are enabled. We check the desktop, the panel, and the menu. We see apps for development, education, games, graphics, and the help center too. We continue with the apps for internet, multimedia, office applications, system tools, and general utilities for all users. We open the terminal and increase the font size for better visibility. Then, we install the necessary test packages via DNF. We run fastfetch. We can see the kernel version is recent, but not the newest. The KDE Plasma version is extremely recent too. We can also see the idle memory, which is very high. Then, we see the installation size on the disk, which is quite adequate. We use commands to contrast the information, which is correct. The version kernel, memory, and disk match well with the data. Then, we verify the boot time with the system analyze command. Removing the firmware time, the measured time is excellent. Now, we run sysbench for CPU on a single thread calculating prime numbers, which measures the single-core performance of chips. In this single-core test, excellent performance was obtained, with good stability in calculation and fast process execution. Then, to measure multi-thread power, we run sysbench for CPU with parallel load, analyzing the scaling efficiency on threads. In the multi-thread test, excellent scaling was observed, taking advantage of the 5 threads with a high increase in speed. When analyzing the scheduler, we run sysbench for CPU and cores, evaluating latency when multiple threads compete for resources. In the scheduler test, controlled latency was observed, maintaining general stability under various concurrent load scenarios. Now we start a synchronization test where we run sysbench for CPU measuring the performance of Mutex logs under high pressure. In the Mutex test, the system showed average log management, with low contention and average performance in parallel scenes. Then we run sysbench for memory in read mode, quantifying the bandwidth and the access speed to the data stored in the RAM part. In the memory reading, excellent bandwidth was reached, with fast data access and stable performance in continuous operations. In order to measure the writing throughput, we run sysbench for memory, analyzing the transfer rate towards the system RAM unit. In the memory writing, an efficient transfer rate was obtained, reflecting a good management of the data flow to the RAM chips. Now, we run sysbench to generate files, preparing a 1 GB environment, which has a good sequential writing speed for the tests. For the final benchmark, we ran sysbench for disk input and output, validating the reading and writing speed in random mode. In the disk test, good performance was not achieved, and it did not improve from the previous version, showing low values. Then we run the top command to check the memory consumed by a Firefox window. Then we open a second tab with a video to test. We continue opening a third and fourth tab, seeing the increase in memory consumption. The average consumption per tab is high. NVIDIA drivers were not installed automatically. We must activate the RPM Fusion repository to obtain this specific driver. We restart the computer to load the corresponding module. Upon entering, we open the terminal and increase the font size. We run the NVIDIA-OPEN command. It says it is not available and suggests packages. We install the CUDA package. We check the setup. We try again, but it still fails to communicate anyway. We set the offload environment variables, but an error occurs here. We proceed to remove the proprietary NVIDIA drivers. We are going to try the Nouveau drivers to see if they can be loaded. We restart the computer, enter the password, and upon entering, we open the terminal and increase the font size for the test. We run NVIDIA-OPEN, but communication is not achieved. We run glmark2 with the variable DRI prime equals 1, but it fails. We remove it. As a third and final attempt, we install the NVIDIA-OPEN drivers. We wait for the installation of the dependencies to finish. In fact, many dependencies are downloaded. It performs the installation of the symlinks, and we proceed to restart the computer. When booting, we see the module loading message. It even stays on a black screen for a long time. We thought it was frozen too. But after a while the boot resumed and it enters the desktop environment. We open the terminal to check if the drivers work. We run NVIDIA-OPEN, but it still fails to communicate. Being open source drivers, we use DRI prime equals 1, but it is not recognized. We try to write the offload and glx environment variables, but in the same way a request error is caused and it does not run. After 3 attempts, it is concluded that old cards are not supported by Fedora. We run glmark2 for the integrated Intel card. We measure the raw performance of Intel by evaluating the frame rate and rendering power under high load, with a low result. We have finished the system evaluation. Below, we present a summary of the results obtained in the tests performed on the PC. In conclusion, the performance of Fedora 44 improved greatly from version 43, except for disk writing, which is still very bad. Out of 3 attempts to install NVIDIA drivers, none worked. However, in Bassite, based on Fedora, it did work for us once. This is all for this video. If you liked it, subscribe, leave a like and activate notifications. See you in the next video.